Well, hello calculus students and seekers of truth. In this video we are going to introduce a new topic called implicit differentiation. But before we get to the precise vocabulary, let's just work through an example as a way to warm up here and also to help us see a different point of view. So we want to find the instantaneous rate of change at the point 0, 5. So what we're effectively doing is we're trying to find f prime of 0, and we also are given that f of 0 must be equal to 5. Okay, so that's effectively the information that we're given. We are given that f of 0 is equal to 5. We're given that this equation is true, and we're told to find f prime of 0. Notice here we're not given an expression for f of x. We don't know what f of x is. It could be a sinusoid. It could be exponential. It could be some other complicated thing. So this is a little bit different. There's no derivative rules per se that we could use to quickly find the answer. But we will start by taking the derivative of both sides. So the derivative of the left side here involves us using the product rule. X is one part, and then f of x squared is another part. So the derivative of the first part is just 1 times the second part, f of x squared, plus the first part, x, times the derivative of the second part, which is 2f of x, times f prime. And so don't forget that the chain rule also applies here. When we take the derivative of f of x squared, we also have to multiply by f prime, because we're really using the chain rule. And then finally, the derivative of this piece right here is just f prime. There's f prime of x. Right? And then the right side, the derivative of 5 is just 0, because 5 is a constant. And then from here, we're going to solve for f prime. Right? So we have this complicated equation, and now what we're going to do is just solve for f prime. So the first thing I'll do is I'm going to move this to the other side, and what I have left here is 2x f of x, f prime of x, plus f prime of x. And that's equal to negative f of x quantity squared. Then we're going to factor out f prime here and here. So we do f prime of x, and what we have left is 2x f of x plus 1. And this is equal to negative f of x squared. And finally, we divide everything, so we get f prime is equal to negative f of x squared. All of this divided by 2x f of x plus 1. And so we've done kind of the hard part of this problem. We got f prime by itself, and all we have to do now is plug in 0 for x, and that should give us our solution. So f prime of 0 is equal to negative f of 0 quantity squared. All of this over 2x, whoops, but x is 0, right? Times f of 0 plus 1. Now, from what we know above, f of 0 was equal to 5. So this is negative 25, because you have f of 0, which is 5 squared here, all over 2 times 0 times something is just all going to be 0 over 1. Okay. So our answer is going to be negative 25. In other words, f of x, whatever that function is, it must have an instantaneous rate of change, or the slope of the line tangent to the point 0, 5 must be, the slope of that line must be negative 25. And I want to point something out here, that even though we don't know an expression for f of x, we don't know what type of function it actually is, based on this equation that we have, we are still able to find the derivative as long as we're given some basic pieces of information. Okay? I'm going to end this video here. In the upcoming videos, we will develop this concept further. And this is something that's called implicit differentiation, and you'll see some more examples as well as some graph. We'll put a picture to this, so that'll make it a little bit more, give you a little bit more detail. But this is a good way to start it if you understand all of the algebra work that we just did here. As always, ask for help when you have questions. Thank you for watching, and have a wonderful day.